This work, use of terrestrial laser scanning to assess fuel consumption in Amazon rainforests, was performed by me, Gabriel Prata, Caio Ramamura, and Professor Luiz Carlos Travis Rodrigues from the University of São Paulo, and Thiago De Conto from Forlider. Fire, as we know, are a major problem for forests. Amazon's fires became topic of worldwide discussion in recent weeks due to the increase in the number of occurrences compared to previous years. Fire consists of three main elements, which compose what we call the fire triangle. Fire needs oxygen, heat, and fuel, and the absence of one of these elements precludes its occurrences. Knowledge about forest fuels enable fire ignition prevention and fire behavior prediction by using fuel characterizations as input in fire behavior models. Terrestrial laser scanning, TLS, appeared in recent years as a novel technology that could provide details from the forest structure and may be good for assessing and modeling fuels. Our aim in this work was to use TLS to assess fuel consumption in a prescribed fire in the Amazon forest by analyzing changes between pre- and post-fire point clouds. Our research was conducted in the state of Mato Grosso, central west of Brazil, in the municipality of Querência, in the Tanguro farm. It's located within the transition zone between the Amazonian and Cerrado biomes, and belongs to the legal Amazonia political division. We used the Faro laser scanner to scan pre- and post-fire plots in a total of 49 scans from 7 different plots. First, we compare difference between pre- and post-fire point cloud metrics. Then we performed a scan angle analysis, where we calculated the difference between pre- and post-fire scans of each angle. First, we compare difference between pre- and post-fire point cloud metrics. Then we performed a scan angle analysis, where we calculated the difference between pre- and post-fire scans of each angle. We generated for each angle graphics where the x-axis were composed by the distance from 0 to 30 meters, and the y-axis were the frequency of points from pre- and post-fire point clouds. We called burn index the area between the pre- and post-fire curves, counting from the scan position and the distance where is identified the first intersection between the lines. We didn't find relevant difference between pre- and post-fire metrics, except for the number of pulses between the ground and the dBH height. These results can be easily viewed on these radar graphics, which illustrate the behavior pattern of normalized box plots from each metric. Burn index also showed greater values in the lower angles. These results corroborate the fact that the largest amount of fuel consumed comes from the first layers of the forests. We conclude that our burn index seems to be a good indicator of fuel consumption, and, as next steps, field sampling is needed to draw better correlations between burn index and fuel biomass consumed in wildfire events. I would like to acknowledge IPAM, Instituto de Pesquisas Ambientais da Amazônia, and the Sustainable Landscape Program. Thank you for watching this video, and please contact us for more information.